Hi everyone, here's a lesson on solving systems using matrices. You can check this out in Chapter 4, Section 5 of your textbook for additional information and examples. You can use the inverse of a matrix to solve a system of equations. This process is similar to solving an equation such as 5x equals 20 by multiplying each side by 1/5, the multiplicative inverse of 5. So you could think of it as dividing by 5, or you can think of it as multiplying by 1/5, which does the same thing. So if I wanted to get rid of the 5 in this equation, 5x equals 20, if I multiply both sides by 1/5, the 1/5 and the 5 will cancel each other out because they are multiplicative inverses. So they cancel each other out to just 1. So on the left side we'd have 1x, and on the right side we'd have 4. So to solve systems of equations with the inverse, you first write the matrix equation, ax equals b, where a is the coefficient matrix, x is the variable matrix, and b is the constant matrix. So let's look at what this would actually look like. So here's a matrix equation, x plus y equals 8 and 2x plus y equals 1. So again, we are going to set this up as ax equals b, where A is the coefficient matrix A, which we've talked about in a previous lesson. So the coefficient matrix will consist of, in the first column, the coefficients for x, the second column, the coefficients for y. So that's where we get that 1 and 2, and the other 1, 1. We multiply that by the variable matrix x, which just stands for what we put the variables, which variables we're using. So in our two equations we have the letters x and y, so our variable matrix will consist of x and y. And then we'll have equals our constant matrix. So we have 8 and 1, so that's how we would set this up. So what we're still going to be solving for is x and y. So to solve ax equals b, if we were just looking at that by itself, without looking at the matrices yet, to get x by itself, we can multiply both sides by the inverse of a to the negative 1, the inverse of a, just like how we multiplied both sides by 1/5 in the previous example. So if we multiply both sides by the a inverse, well, a to the negative 1, or the inverse of a, times a will give us 1, or what that looks like in a matrix is I, the identity matrix. And then we get x equals a to the negative 1 times b. Remember, the identity matrix is on the first diagonal 1s and everywhere else of 0, and that's just the same thing as 1 whenever we're multiplying by matrices. But here's a very important thing. Matrix multiplication is not commutative, so it is important to multiply by the inverse in the same order on both sides of the equation. So a to the negative 1 comes first on each side. If you try multiplying in the wrong order, you will not get the correct answer, or maybe not even an answer at all. So let's look at an example. Let's write the matrix equation for the system and solve. So we have 2x plus 5y equals 0 and 5x minus 3y equals 31. So the very first step that we need to do is set up the matrix equation, which is a times x equals b, where a is the coefficient matrix, x is the variable matrix, and equals b, the constant matrix. So a, being the coefficient matrix, will be 2, 5 from the coefficients for the x, and 5, negative 3 from the coefficients for the y. Our variable matrix, we're using the variables x and y for this system, so that's x and y, equals b, our constant terms, so we have 0 and 31. So we're going to find the determinant, so that way we can find the inverse of a. So let's find the determinant. So the determinant of a is the difference of the cross products, right? So 2 times negative 3 is negative 6 minus 5 times 5, which is 25. So our determinant is negative 31. Remember, if that had been equal to 0, we wouldn't have an inverse, but here this is not equal to 0, so we do have an inverse, which is great news. That means we're going to get to solve this system. So now that we know the determinant is negative 31, let's find the inverse of A. A is equal to 2, 5, 5, negative 3, which was our coefficient matrix. So for the formula of the inverse of A, we do 1 over the determinant of A, which was negative 31, and then we multiply it by that thing that I often call the flip-flop matrix. The first diagonal has been flipped so that the 2 and the negative 3 switch spots, and then the second diagonal was multiplied by negative 1, so now they're both negative 5. Lastly, we need to distribute the 1 over negative 31 into the matrix. So there we get a bunch of things over 31. So now that we know what the inverse of A is, we can multiply both sides of our matrix equation by the inverse of A. So there was a step that's kind of skipped here. Instead of you seeing A inverse times A times X, well, it's just shown here that A times A inverse canceled each other out, so we were left with the variable matrix equals the inverse of A times B. At this step, you would be able to just type these two matrices into your calculator to multiply, and you would get 5, negative 2. Again, make sure whenever you are multiplying that you are always putting A inverse first, then times B. So let's look at another example. But before we do, shout out to Kate, John, Holden, and Arjun. Hope you're taking good notes. Okay, so let's write the matrix equation for this system, x plus y equals 4, and 2x plus 3y equals 9, and solve. So step 1 is to set up the matrix equation. A times x equals b. Okay, so A is the coefficient matrix, so we're going to get sorry if it's a little messy. We'll get 1, 2, 1, and 3 because those are the the coefficients in front of the variables x and the coefficients in front of the variables y. So we get 1, 2, 1, 3. Our variables that we're using are x and y. So we'll just write x, well, that's definitely messy, and y. And then that will be equal to our constant matrix, B, which is 4 and 9. Okay, so for the next part we need to find the determinant. So the next part we have the determinant, so then the determinant of A is going to be, so we have on the first diagonal we have 3 times 1, and we're going to subtract the other diagonal, 2 times 1. So we get 3 minus 2, or just 1. So now we know the determinant of A is 1. So if A was 1, 2, 1, 3, the inverse of A will be 1 over the determinant of A. Well, the determinant we found out was 1. So 1 over 1 is just 1. That makes this really easy. Because when we distribute that into this matrix where we flip-flopped everything, the first diagonal, the 1 and 3 were switched. And then the other diagonal we multiply by negative 1. So 1 times each of those things. The inverse of A is 3, negative 2, negative 1, 1. So now what we need to do is take AX equals B and multiply both sides by the inverse of A. So A times the inverse of A inverse times A will just give us the identity matrix. So our left side will just be left with the variable matrix, and our variables will be equal to the inverse matrix of A times B, our constant matrix. So let's go ahead and take a look at the calculator really quickly because we need to multiply these two things together. Alright, so here's our calculator. On the left hand side you'll see the keyboard or the keypad for the calculator, and then on the right hand side you see the computer screen. So we're just going to go into a calculator screen. It doesn't matter if it's a scratch pad or not. But what we need to do is get the matrix on our screen. So the inverse of A was a 2 by 2 matrix. So if you click this little button just to the right of the number 9, you'll see this pop up. And on that second row you see a 2 by 2, a 1 by 2, a 2 by 1, and this 3 by 3 is actually so that you can customize which size you want. But for now we just need a 2 by 2. So we have 3, -1, -2, and 1. And we need to multiply that, so times, and we need another matrix for B, the constant matrix. So again, I'm going to click on that button, and then if I move over a little bit here, I have a 2 by 1 matrix, so I'm just going to click on that one, and for those numbers we have 4 and 9. So I just hit enter, and my solution is 3, 1. So then we would just go back over to our paper and we write down an ordered pair of 3, 1 like that. Okay, well, that's it. I hope that that was clear enough. We'll be looking at some other examples in class if you need to. But overall, you're just going to have your notes and meet tomorrow in class. If you have any questions, just let me know. Have a good evening.